Physiological interaction goes beyond the physical interfaces that a computer has, which would include the input and output devices. Physiological interfaces actually secure and use real body characteristics, including breathing, talking, and height and weight. Some of the top innovations include automatic speech recognition, virtual reality, cave automatic virtual environments, and biometrics. Automatic speech recognition. The automatic speech recognition system will capture spoken words and then classify word groupings to form a sentence. ASR is computer-driven and transcribes spoken language into text that can be read by using real-time. Special applications for this system may be used to help deaf and hard-of-hearing people understand what is being said. This technology is becoming more popular in computing environments as well. Call centers are taking on automatic speech recognition in order to decrease the amount of clients who hang up because they are not talking to a live operator. In order for an ASR system to function, it must follow 3 steps. The system will capture words that are spoken into a microphone, while taking out any background noises, and then converting the digital signals of the speech into syllables. This is referred to as feature analysis. Next, the system will match the spoken syllables to a phoneme sequence that is kept in an acoustic model database. This is called pattern classification. The system will then try to make sense of what is being said by comparing the word phonemes from the previous step, this time with a language model database. Virtual reality. The second physiological innovation is virtual reality, which is a 3-dimensional computer simulation in which a person actively and physically participates. Virtual reality has been used to train astronauts at NASA. This type of interaction uses special input and output devices in order to take physiological movements and send responses back to the person. Virtual reality includes 3 devices: a glove, a headset, and a walker. A glove will capture and record the shape and movement of your hand and fingers and the strength of the movements. A headset records your head's movement and contains a screen that covers your entire field of vision and displays various views of an environment on the basis of your movements. A walker records the movement of your feet as you walk or turn in different directions. Virtual reality is applied everywhere and can be seen in the entertainment industry, for example, including virtual reality games, automatic virtual environments. Another part of physiological interaction innovations are caves, which stands for automatic virtual environments. The cave was first thought of by Thomas DeFanti and Dan Sandine and was later developed at the Electronic Visualization Laboratory at the University of Illinois at Chicago by Carolina Krusnera. It is similar to virtual reality, except you do not need any gear on your body in order to see the images. In these virtual environments you are able to see 3D images of other people or things that are also using a cave in another location anywhere in the world. The purpose is to make people feel as if they were in the same location as the people or things they are interacting with. In order for the cave to work, it must present many of the same cues your brain uses to interact and understand the world around you. There are 4 different systems that must be implemented into the cave in order for it to work properly. The first being computers that are needed to coordinate all of the other equipment. Another component are graphic systems, which are very important. Every second there are 96 different images are displayed each of the cave's 4 walls. This produces very high resolution. In order to make the cave seem real, sound need to be taken into consideration, sound system. And the last system that is needed for the cave to work is a tracking system, which is used to track the position and orientation of objects in the cave. Biometrics. Biometrics is the use of data gathered through physiological interactions with sensors to authenticate human beings. Examples of biometric modalities include fingerprints, iris scans, facial recognition systems, and DNA analysis. Networking multiple biometric modalities over several geographical locations greatly increases the reliability and security of biometric data by providing redundancy and provenance for biometric data. Future uses of biometrics based on physiological interactions could include transaction authentication, medical record management, customer information, and global security. A properly designed and encrypted telebiometric system could include much more robust fraud and identity theft protection than current practices. With our bodies and habits as the ultimate authentication of our identity, the full array of biometrics would be difficult to steal or replicate because everyone has unique biometrics. The next step for businesses gathering information about their customers is going to include the tracking of biometrics. BPS or biometric processing systems are going to record and process physiological characteristics. With even more information about customers, companies will really be able to target the market. There will be problems with customer protection and privacy. Many customers already feel business know too much about them and would feel uncomfortable with the idea of businesses having access to extremely personal information. There are several different technologies that have evolved because of biometrics. To name a few, there are biochips and implant chips. Biochips are designed to perform physiological functions that help your body when they are inserted, for example, reduce pain for those that suffer from injuries. Another technology that has come out of biometrics is implant chips. When they are inserted into your body, they store information about you or your body. So if you were ever in trouble, the chip can be scanned and all the important information about you will be right there.